Today we are going to discuss the next part of the first chapter, sets. Now I'm going to explain all about equal sets. Equal sets means what condition we apply. First I define how we understand the two sets are said to be equal. If A and B are two sets are said to be equal if they have exactly the same elements. Whatever the elements in A, the same elements in B, then they are said to be equal. If not, otherwise they are said to be unequal. So here I want to explain with one example. Suppose if you say A equal to 1, 2, 3 and B is equal to 3, 2, 1. A and B are two sets. And you see, here the elements is 1, 2, 3. Here the elements is 1, 2, 3. They have the same elements. And then only we can see that A is equal to B. What is the definition now? Coming to the end, two sets A and B are said to be equal if they have exactly the same elements. This is example. And one more example I am giving you to say that equal sets. And finally I come to that the condition may be slightly different with certain cases. Even then we say that two sets are generally equal. So one example which I say now here, when you say that two sets are said to be equal, the letters of the words, you can see this follow I write. F-O-L-L-O-O. Follow I take. This is one letter. Here we have to understand that the set of all this and the other one is wolf. See here, these are two letters. So let us say this is the set of letters. We can write F-O-L-W and this refers to set B. Here W-O-L-F. See here? 1, 2, 3, 4, 5, 6. Here I have written 1, 2, 3, 4. Why? Because repetition L we have to take only once. And here repetition are always taken only once each. And here wolf. So here F is there, O is there, O is there, L is there, L is there, W is there. So these are again A equal to B. The set of letters of the word follow, the set of the letters of the word wolf are equal. Why? They have exactly the same elements. Suppose if you take one set for general, I take 1, 2, 3. This is exactly equal to 1, 1, 2, 3. This is exactly equal to 1, 1, 2, 2, 3, 3, 3. See, all are equal I have told here. Why? Because repetition is not at all because meaningless. So here also 1, 2, 3, here also 1, 2, 3, here also 1, 2, 3. That is why such sets When you take the repetition of the letters in the word, no meaning at all. That is why repetition of the letters are taken only once each. So this is all about the equal sets. So what I say now here, finally, two sets are said to be equal if they have exactly the same elements. And here with the examples I have told. But now I am giving you one specific problem that I have to explain here. Show that, look this, show that 1 is 5 and this is null set and 0, see, or this is 0 are all different. You are studying this, how all they are different. Look here. This is null set and this is not a null set. It is a set having one element, singleton set. And this is null set, empty, which has no elements at all. And this is not equal to this. This, if I write only like this, it is a null set, but it is having one element, 0. So this is the null set. You have to write which has no elements, and this is a set. This is a singleton set, and this is not at all the set. It is the element of the set. 0 is the element of the set. So definitely all are different. Once again I repeat, this is a null set or empty set. This is singleton set which has only one element, and this is not at all the set which is the element of this set. This is the difference of all these things. That is why you try to understand that if the set is having 0, it is not a null set and it is a singleton set. Singleton means the set is containing only one element. So now here you have to see that basically when the two sets you are taking, always you consider that same, exactly similar type letters, numbers, objects. But now I want to say one more word we are using, equivalent sets. What do you mean by equivalent sets? Look here. So far I have told you equal set. Two sets are said to be equal if they have exactly the same elements. But when you say that equivalent sets, suppose this is A and B are two sets, and when they are equal, if they have exactly the same elements, when they are equivalent sets, if here you see one symbol we write that suppose the set A is containing 1, 2, 3 and the number of elements in the set is 3. So that we write symbolically n of A equal to 3. N of A means the number of elements in the set. So here I want to tell the number of elements of the set A is equal to number of elements of the set B equal to, then they are said to be equivalent. So I hope you have understood that equivalent set means what? Equivalent means the number of elements in both the sets are same. Now I want to compare with equivalent sets and equal sets. What difference is there? Equivalent sets and equal sets. Look this, I am explaining here. Let A equal to 1, 2, 3 and B is equal to 5, 6, 7. So A and B are equivalent sets. Why? Number of elements in A equal to 3 and number of elements in B is also 3. If the number of elements in both the sets are same, then they are equivalent. But A and B are not equal. A and B are not because they have different elements. So you take it grant, equivalent sets are always, you cannot say that equal set, but equal sets are always equivalent. Whichever the equal sets you say that, and ultimately equivalent. But reverse, converse need not true. What do you mean? All equivalent sets need not be equal sets. So I hope you understood that equal set means exactly the same elements. Equivalent sets means the number of elements in both the sets are equal. N of A equal to N of B. So this is all about equivalent sets. Now I want to discuss that particularly. And if they are having N is, suppose this, look this one more example I am giving you, 1, 2, 3, and B is having 1, 2, 3, 4, and these are not equivalent. Why? N of A is 3, N of B is 4, N of A is not equal to N of B, then they are called not equivalent sets. And I hope that when you see that they are having different number of elements in the sets, and they never be called equivalent sets. Now this is the end of equal sets and equivalent sets with examples. Now I am going to discuss about the subsets. So try to understand subsets. Next head is subsets. Because already you know that sets. Now we have to see that when you say that subset, suppose A is a subset of B, we write. A is a subset of B. A is a subset of B. We write like this. A is a subset of B. This is a symbol for the subset. The set A is said to be a set B. In what condition? All the elements of A are in B. Means that the elements which you can see are definitely in B. That means to say, if every element of A must be in the set B. So try to understand that A is a subset of B means every element of A is the element of B. Every element of A is the element of B. Then we say that A is a subset of B. This is a symbol. Try to understand symbol. But more in general we write like this only. But I tell you later what is the difference. Even in some books we write like this. But here I am giving clear picture why we write so. And try to understand that set A is called a subset of set B if every element of A is the also element of B, then we say that A is a subset of B. And here you have to see that particularly if A is subset of B, if I write like this, A is subset of B, then you can understand this, what do you call this? Exactly same. B is called superset, you can tell here. And here we have to see that B is called the superset. This is A is subset of B. If I write like this, what we call? B is called superset of set B. Superset, you know that? That is all elements of A are in B subset. And here you can see that B is superset. But B contains all the elements of A. That is called what you say superset. Symbol is like this. This is A is a subset of B. This is B is a superset. Superset, you remember. And you cannot say that every element of B in A, not like that. So only we are told that every element of A are also the elements of B, then only it is a subset. In such a condition, B is nothing but superset of A, we can tell. Now one more condition here I am going to explain in case of subsets. So what already I told you, this is A is subset of B. And suppose if here you have to see that A is not equal to B. If A is not equal to B, and even you can see that A is a subset of means sometimes A equal to B is quite possible. And when you say that A is not equal to B, then here you have to tell that A is subset of B. And here not only the subset word we are using, A is proper subset of B we can write. Try to understand. If I write what is the meaning now, you can see A is a proper subset of B. Proper subset, when that word is used, when A is not equal to B. When A is not equal to B, then A is a proper subset of B. Suppose if I write like this, simply A is subset of B, and we are not using proper. Proper means, because you can say that A may be equal to B. This here word you are, this is may be equal to A. When this is not equal, and A is a proper, and unequal, only the subset. So try to understand, when A is called proper subset of B, if A is a subset of B in which A is not equal to B, then A is called a proper subset of B, you can say. And basically you try to understand that. In general, if you see that, if you take any set A, general point I am telling, every subset is a subset of itself. We make it understand these very important characteristics. Every set is subset of itself. A is subset. And one more condition, very important condition, is that null set is a subset of every set. You see, A is a subset of A, means that every set is subset of itself, and null set is subset of every set. So these two important conditions are to be followed here, and I hope that here the important terms that you have seen in case of subsets, superset, proper subset, and also you can see that every set is a subset of itself, and every empty set is the subset of every set. So this is the case you can understand here. And basically when you go for set of natural numbers, the set of natural number is n. Natural number is subset of that is W. W means you have to understand the whole numbers. Generally called W is nothing but what? Whole numbers that you can see. And this is a subset of integers. Z is a integer. Z is integer, and this is subset of I. Here Q you can say. Z is integer, it is a rational number, and this is a subset of R. R means set of real numbers. Make it clear understanding that what? Set of natural number, set of whole numbers, set of integers, set of rational numbers, set of real numbers. See that set of natural number n is subset of the set of whole number. Set of whole number is subset of set of integers. Set of integer is subset of set of rational number. Set of rational is subset of set of real numbers. So that is why you can say. But one thing we understand, W is not subset of n. We write like this. Why W is not subset of n? And you have to explain that why it is not possible. Because in case of W, 0 belongs to whole number it comes, but 0 does not belongs to n. And 0 is there in whole numbers, but 0 is not there in the natural number, so that it is not a subset, you can tell. And make it clear understanding that 0 is not included in the set of natural numbers. So I hope you have understood how the set of real numbers, we take it under the subset. And one thing it is clear that when the set you are writing subset, we write like this, and sometimes we write like this, and when you write this is a proper subset, that time you have to say A is not equal to B. And this is the case, and this is the end of subsets, in which proper subset and superset, and also you have consider that important characteristics. And when you see that, one more property I want to explain that in general. What? Suppose A is a subset of B and also B is a subset of A. This implies what? A equal to B. Try to understand. We write like this. What is the meaning? A is a subset of B and B is a subset of B, and this is two-way implications we tell. Two-way implication means if A equal to B, then these are possible. When these are possible and this is possible, you can use in mathematics if and only if. If and only if we write, but in shortcut we write IFF we write. This is nothing but what? IFF means if and only if. If and only if means two-way implications. Two-way implication means what? If this is the case and this is true. If this is the case and this is conversely also satisfied in the case of two-way implications, or you can say if and only if conditions that should be followed. Now here we have to discuss subsets of, look here, subsets of set of real numbers. I want to discuss briefly about this. Subsets of set of real numbers. And now you have to understand that which are the set of real numbers. Which are the subsets of set of real numbers? Set of real numbers is denoted by, you know, this. And a set of real numbers, always you consider this is 0, and here you say this is infinity and this is minus infinity, and all the numbers existing on this number line, whole line is called a set of real numbers. And this you can write symbolically minus infinity to plus infinity. This means I have to say that it's an open interval, and means it can be extended either side, and this is a whole real line, that is called number line or whole line you can say. So now which are the subsets on this number line that we are discussing, we are giving. First of all, set of natural numbers. Which are these natural numbers? 1, 2, 3, 3. See here up to infinity we can say, because the end of natural number is not fixed. So you have to say that 1, 2, 3 up to that, and the set of natural numbers, and this is the subset of natural number. See, try to understand, set of natural numbers is subset of set of real numbers. Set of real numbers, that already you see. Here we can see from the right of this 0, that two whole numbers are called natural numbers, and this is also the subset. And the second one you have to go for writing that whole numbers I take. Whole numbers means what? See, this whole numbers means 0, 1, 0, 1, 2, 3, and here you have to see this minus 1, minus 2, you can extend like this. And here also the set. And particularly here we have to tell that when you are considering the whole numbers, and whole numbers is never be taken as negative, and we have to consider as positive. So here when you see this up to this stage, and this is nothing but whole number. Whole numbers means denoted by W, and W is 0, 1, 2, 3, 4, 5, and this W is also the subset of real numbers, set of real numbers. And you see that whole numbers are 0, 1, 2, 3, 4. And here when you see that set of integers, when you take it that, and it has to be like in this 1, minus 2, minus 3. So this is what? Set of integer. Set of integer denoted by Z. Z is also subset of R. I am not writing this. Why? Because it never be equal, you know. That is why you have to write in this. Set of integer is also subset of real numbers. And one more, the last case we have to see that rational numbers. Set of rational number. Set of rational number is nothing but you know, which are in the form of P by Q. So set of natural number, that is X, such that here always you understand rational number which are in the form of P by Q. And here you see that X is equal to P by Q quotient, and Q is not equal to 0. Try to understand every number in the form of P by Q, and Q is not equal to 0, and both P and Q are the integers. Both P and Q are the integers. So this is a set of rational numbers, and in which we can see the number in the form of P and Q are the integer, and Q is not equal to 0. These are set. This set is also what? Subset of real numbers. So we have studied now which are the subsets of set of real numbers, and this is the case what we can see that even you tell that particularly one more number we can discuss, that is called if I say that root 2, root 3, these are not at all rational number, these are called irrational numbers. Suppose T is the set of irrational numbers. T is the set of irrational numbers means the numbers which cannot be written in the form of P by Q. The numbers which cannot be written means that X not in the form of Q. See, this you can write X such that here you have to write that particularly X not in the form of P by Q. What you have to tell now here, that this belongs to R, but here X does not belongs to Q. X belongs to R means that the set of irrational number must be the real number, and which is not a real number. So this set is nothing but set of irrational. Set of irrational, that must be the real number, and that should not be the rational number, and that is called irrational number. So what conclusion? This is also the subset of R. Set of irrational numbers is also what you can say that subsets of R. These are the subsets of set of real numbers. Now coming to the next, here we are discussing that regarding the subsets of sets of real numbers, that we have taken N, Z, Q, T, so even W whole numbers, and that we have taken. So the next part here, and intervals as a subsets of R. This is very important. Intervals means how you take it. Intervals as subsets. See, particularly we are taking the particular intervals, and that is nothing but subsets of R. Look this, subsets of R. Intervals as subsets of R. So far we have seen that subsets means what, but here I want to discuss that intervals are also subsets of R. For example, one example I am giving you, let two real numbers I am taking, A belongs to R and A is less than B. This is the condition we put to write the intervals. Now here we want to write some intervals, basically intervals as a subsets of R. And there I want to tell the two conditions that I have to apply. So try to understand intervals as a subsets of R, and here I already have told you AB belongs to R and A is less than B. With this condition we go for dividing two types of intervals. Intervals as a subsets of R, we take only two types. Intervals as a subset of R means here intervals are particularly we have to divide in intervals as a subsets of R means two, and which are the two that I am explaining here with this line diagram. And try to understand there are only basically two important intervals, and sub intervals or half closed, half open intervals that we can say. But now here I have to tell that first one is open interval. What I have to write? This is open interval. First, see, intervals as a subsets of R means one is open interval and the other one is closed interval. See, there are two types. First, basically we understand one is open interval and other one is closed interval. So when the open interval symbol we write here like this, you see AB, you write it, and the symbol for a closed interval we write AB. Try to understand the symbolic representation. Once again, intervals as a subsets of R, two types. One is open interval and other one is closed interval. Open interval we write like this, closed intervals we like this. So one thing here you may write in other fashion, and accordingly we can write it. This can be written as, suppose A is less than x, x is less than b. This is also the symbol for what? Open interval. Open interval means x is greater than a and x is less than b. That is nothing but open interval. And in closed interval, the symbol you write that x here, a is less than or equal to x, x is less than or equal to b. So the symbol you understand. Here only strictly we write. Here we write less than or equal to. So you try to understand, this is a symbol for closed interval and this is a symbol for open interval. But here I have not explained what exactly the difference. The difference is that in this open interval, A and B are not included. Here you have to take all those values which are between A and B, not A and B. Try to understand. All those, because one thing basically understand, in the interval infinite number of points you can see. In the interval how many points you can see? Infinite number of points. But here in between A and B you have to take any number, not A and not B. Between A and B you have to see. In open interval what you have to see? All the points between A and B. Here not only all the points between, here A and B are included. The points in this case including A and B. The points you have to see that including A and B, and particularly you have to see that closed interval. Once again I repeat, in open interval A and B not included. In closed interval A and B included. So once again, open interval means and the points which are between A and B. Here not only A and B, not only between A and B, but also A but also B. Means that A and B are end points are included. Where? In the closed interval. So most of the students getting confusion with the symbols and the explanation. Open interval means symbol like this. Open interval symbol like this. Here A and B are not included, whereas in closed interval you have to see that symbol is like this, symbol is lesser than equal. It means to say the points not only in between A and B but also A but also means A and B are included. This is the basic symbol that we can understand. And one more line diagram I have to explain. What line diagram? Suppose if you say these are the intervals are the subsets of what? Set of real numbers. Suppose if I take one real number, if I take this A and B, this is A and B, and try to understand here how this open interval is represented. And here also I write that this is a line, and here I write A and B. So A and B, here is the closed interval and here is the open interval. And what is the symbolic represent for this, that I explain. So in open interval we write like this. Look here. This is a open interval. Open interval means these are small circle, you know, here it is empty. Whereas here we take it, here you see. And here small circle are empty, no, this should be darkening, you have to say. See this? Yes, I hope you understood. In open interval these are empty. In closed interval these are not empty, they are fully darkened. So this is exactly the difference between open interval and closed interval. Once again I repeat, A and B are the two real numbers. A is less than B and one is open interval, other one is closed interval. Open interval symbol is like this, in line diagram is like this. Here the points between A and B, whereas in closed interval three types of symbols that we have used. One is this, other one is this, and third one is this. Here points not only between A and B, even the end points A and B also included. This is what we say intervals as a subsets of a. But in addition to this, we say some other intervals that I am explaining. You can see that semi-closed intervals, you can say. Semi-closed intervals. And what semi-closed? You can go for like this. Suppose if I write, see, this is A, this is, look this. Here opened at left side and closed at right side. And here you can say this. Here opened at B and closed at A. And you try to understand what makes the difference. You can see this two. This is a semi-closed intervals, we can say. And try to understand, this is an open, but in general we tell this is an open interval from A to B. A is not included, B is included. I hope you understood this. This is the open interval from A to B. A is not included, B is included. This is an open interval from A to B. A is included, B is not included. I hope you understood that included, not included. And line diagram, see this, you can write this. It is open, you know, this, you can, open means like this. It is like this. Yes, you understood this? When it is open, you know, you have to write only single. It is closed, you know, you have to write like this. And here also you can write X, it is closed and it is opened. So yeah, I hope you make it difference here, writing the symbols. It is opened at the end A and this is not included, and here B is not included. So in a line diagram also we can see, suppose this is A and B, what I say here, one line here, and here at the end B it is darkening, at the end A is, it is empty. I hope you understood this semi-closed intervals or simply open intervals we can call. And similarly in this case, you try to understand in the interval A and B, and here also I that it is open at B, see, and closed at A, and this is the case with it is open interval from A to B, and here you understand that A is included, B is not included. These are the subsets. These are the subsets of the set of real numbers, and accordingly you can explain that how we use these intervals in future studies. Now I want to explain some other things which can be taken, that negative numbers, non-negative numbers also we tell. So I hope that these types of intervals you have understood. And now I want to give some intervals which we use in our studies. That part I am discussing here. And if I take one example that, and you have to write this example I am writing here, the set, look this, the set X such that X belongs to R minus 5, this is X is less than 9. So what is this? This is one point it is in the set builder form, you know. All the elements are in the set of real numbers, that too, see, X is greater than minus 5, lesser than, and it is closed and it is open. What I mean to tell, this is a set builder form is there. Set builder form, this is also the subset of a set of real number. Set builder form can be written as in the interval form. So how you can write in the interval, that also you have understood. But here one thing it is true that how this should be written. So this can be written as, how you write, you tell me, minus 5 and 9. Yes, correct or not? This is in the interval form. This is in the set builder form. Here you are write open interval, whereas you are closed. Why? Because of this condition. And this is also the subset, and this is also subset, but this is in the set builder form, it is in the interval form. I hope you have understood that how we go for. Now I am writing one example, that reverse order. Set builder form or roster form or interval form, they are all the subset of set of real numbers. So one more example I am giving you to write here. So first I write, interval form I write. The interval, if I write one example, you have to give, this minus 3, 5. In this I write. So you can write in the set builder. It is in the interval form, this. And how you write in the set? In the previous example, set builder form to interval form. Here interval form is to be written in the set builder form. How you say? X such that, you look this, X is, look this, and try to understand. And where it is closed, and you have to see this is minus 3. Where it is closed, and here it is not closed. X is greater than or equal to minus 3 and strictly less than 5. And I hope you understood this, why we have written like this. And this is set builder form. This is interval form, and this is what you say, set builder form. Now I write one more example, because you must easily understanding that how the subsets can be formed in the various parts. Third example I am giving here. You see this. Suppose if A is equal to minus 3, 5, and see, what do you mean this minus 3, 5? How you write in the set builder form? If you write like this, how you write this set A? A is equal to, you have to write, this is minus 3 and this is 5. Yes, you understood this? And basically you can go for writing these elements A equal to Y, both are open, so that strictly I have written. And B is equal to, suppose if I write B is equal to, suppose minus 7, 9. So here I have closed interval. Then how you write this? And try to understand minus 7 is less than equal to 9. Yes. Look this, how we have written interval and set builder form accordingly this. But one thing you observe, whatever the elements of A, they are in the set B. So ultimately A is subset of B. Look here, the elements which are in this set are also in this set. Every element of the set A is in set B, then A is a subset of B. This is one example I have written interval form and also set builder form. One more notation I write, you must understand, more general we use in second PUC. That time you must understand what is the meaning. Suppose if I write, you write the set, one set I am writing, why you write like this? So what is this meaning? What is this? This is set, it is closed at 0 and opened at infinity. Wherever infinity is there, you cannot write this. Do you know this? We cannot write. Why we cannot write? Because infinity is not a number. It is only the symbol which gives infinite meaning. It never, infinity will never be included in the set, because nobody knows where the infinity lies. That is why it should be between. So before infinity, whatever comes, that we write. The set here we write, and try to understand. Suppose if you write a real number and here 0 up to infinity. These numbers are called what? Including 0, I am telling. Including 0 up to infinity, these numbers are called what? You have to tell that non-negative numbers. Here, if you come 0 this side, negative numbers, this positive numbers, and non-negative means 0 to infinity. This is the set of non-negative. Do you know non-negative? Here is there any negative? No. And non-negative means excluding negative. But 0 is positive or negative? 0 is neither negative nor positive. When you are what do you say, dropping negative, 0 must be included. 0 must be included. That is why we have written not like this. We have written like this. Why? 0 must be included in the set of non-negative numbers, non-negative real numbers. This is a set of non-negative real numbers. Once again I repeat, non-negative means you have to see that only positive and 0. Try to understand. Non-negative means all positive numbers including 0. That is set of non-negative real numbers, you can say. So that 0 is included, infinity, and by mistake if write it mean no. I think that no meaning, because never be included in the set. So this is a set of non-negative real numbers that you can say. And basically, suppose if I write like this, what do you say? If I write like this, minus infinity 0. So here you try to understand what is this. Here minus infinity is not included and 0 is also not included. These numbers are called what? For example, see this. This is 0 and up to infinity, up to minus infinity extended, and 0 is included or not included. If I write it like this, 0 is not included, 0 not included, all these numbers are called what? Purely negative numbers. Don't say that purely, because negative numbers are always negative, no question of adjective pure. Minus infinity to 0, if you write this bracket, it is a set of negative numbers, you can say. Set of negative real numbers, you can say. I hope you understood why you are not supposed to write. If I write like this, 0 is included and 0 is not a negative number. So that is why we used to write like this only. So minus infinity to 0, this is an open interval and the set of negative real numbers that you can say, and accordingly you can understand the result here. And finally I have to tell that if I write, what do you mean? Minus infinity to plus infinity. So you have to write like this only, because these never be included, because they are not at all the numbers, they are the symbols. And this is what? It is a set of real numbers and extended on both sides. So up to this is the case. How you say this? This is 0 if you say, and this is plus infinity, and this is minus infinity. This is whole real line is called. This set is whole real line. And generally it's called a number line, we can say, or this is denoted by what? This is denoted by set of real numbers. The set of real number, the whole numbers minus infinity to plus infinity, the numbers which are existing on the line, they are called the real numbers. And last in case of interval I am giving you, that is the length of an interval. What do you mean by length of interval? I am explaining. So the length of an interval, how we take it? Which interval? Any interval, open interval or closed interval or half, means semi. Look this, either like this or like this or like this or like this. Yes, all are different or not? See, 1, 2, 3, 4. In these 4 intervals, and you know this is open interval, this is closed interval, this is, that is from A to B, understanding that including no, not including A, including B, including A, not including B. The length of an interval is denoted by B minus A. So now what I mean to say, B minus A is called length of an which interval? Any interval you can say. All 4 intervals you are considering, in which the length of interval is taken as B minus A. Now what is B minus A? The quantity B minus A is nothing but a length of an interval, you can say. So I hope that today whatever we have discussed about the intervals, and it is very important for the things to be considered, and accordingly you can go for. So that in the next class I want to explain power set, and one more important is that intersection and union of sets, that in which you can see that Venn diagrams, and finally you can see that complement of a set. So the only 4 parts are to be discussed. Now power set and intersection, union, Venn diagram and complement of a set. These 4 points, 1, 2, 3, 4, 5 points are to be discussed in the next class, and that is the last class. What I have to define next? What is power set? Power set is nothing but set of all subsets of a set. Suppose if you say, what you say, A is equal to 1, 2, 3. 1, 2, 3. What is this? It is a set. And here we have to tell that how many subsets are there here? Look here, this is a set. I want to explain here power set. Today, better you complete power set. We'll see that next part. Power set means I'm explaining. Suppose A is the set, and which are the subsets here? 1 is also subset. Which are the subset here? 1, 2 is also subset. Which are the subset here? 1, 2, 3 is also subset. And even I tell you that null set is also the subset. So how many subsets? 1, 2, 3, 4. Then you can see that how we take it all these, and accordingly you can consider. And these are the subsets you can consider. And the set of all subsets, you can say. What you say? The set of all subsets, even you go for taking, and are the power set. Suppose in briefly speaking here, in shortcut, A equal to 1, 2, and in one is null set, other one is single set, and here you can see 1, 2. So these are the subsets of a set R, and basically you can understand that when you go for 3 sets, that 1, 1, 2, and also you can see that particularly you have to go for single. 1 is also there, 2 is also there, and even you can go for one more that. See this once again, 1, and here you are 2 also you taken 2 and 1, 2. So here you have to see how many subsets? 1, 2, 3, 4. And here you have to go for how many subsets you have got it? 1, 2, 3, 4. 1, 2, 3, 4. The formula is 2 raised to m. M stands for the number of elements. That is 2 square equal to 4. See, the number of subset is formula is 2 raised to m. Suppose if you say 3 elements, and you have to go for 2 raised to 3. 2 raised to 3 means how much? 8 subsets. So here the formula I have given 2 elements, 1, 2, 3, 4. So here you see the set of all these set is called power set. Power set is denoted by P of A. P of A is nothing but what? Power set of A. Power set of A means what? Set of all subsets of A is called power set of A. And here you have to see that particularly the number of elements in the power set. How you say? The number of elements in the number of elements in the power set. Power set means P of A. See, look here. The number of elements in the power set is formula is 2 raised to m. This is the formula. What is m? M is the number of elements in the set. What is m? M is what? Number of elements in the set. Suppose if you say n is the number of elements in the set. Look this. If n of A equal to m, n of A means the number of elements in the set A is m. The number of power set is equal to 2 raised to m. This formula is to be remembered. Once again, power set means you have to see that set of subsets of A, and here you have to see that that number of power set n of A is 2 raised to m. M is the number of elements in A. So this is all about the power set with the example I have told you. But now you have to go for taking before discussing the Venn diagram. Venn diagram means intersection and union. When you see that Venn diagram, and you must know the universal set. What do you say? Universal set. Without understanding universal set, you cannot go for Venn diagram. So I stop it, just a completion of power set. In the next class, now I am not discussing this power set, I am discussing the universal set and Venn diagram. What do you say? Venn diagrams. So I stop here, power set. Finally, I repeat, power set means you have to see that particularly set of subsets of R, and the number of elements in the power set is 2 raised to m, where m is the number of elements in the set A. So I hope you understood all about the things. In the next class, only thing is that Venn diagram and complementarity of the set A, only 2 parts left out. After that, this is the end of this first chapter sets, in which you know already 8 marks they ask. That means part A 1 mark they ask, 1 mark. Part B, that 2 marks, that is 2 plus 2 4, because 2 questions they ask in part B. In this is A, this is B. In part C in mathematics, here you can see only 1 question, and that 1 question is carries 3. So totally 8. Means that in part A 1 question, part B 2 question 4 marks, in part C 1 marks 3 question. So totally 8 marks definitely you will see out of 100, and if you have understood everything about this chapter. So the next class I want to close, I want to complete this first chapter sets, and in which what are the things you have studied and what are the things to be studied in the next class, that already I told you. Only thing is that Venn diagram, in which intersection, union of sets and complementation. Thank you.